So hi everyone. As Patrick mentioned, my name is Maël. I'm a senior software engineer at Datadog, and on my part time, I'm also leading the development for Yarn, the package manager. I've been a long-time fan of custom renderers in React. In fact, 3 years ago, I made a presentation about one of them at Paris.js. And I figured that it could be interesting to make a quick presentation of what they are, why they're useful, when not to use them, and show you some example of the one that already exists. So first, we need to discuss a bit about what is actually React. We all use it, but how does it work exactly? If you go on the React website, the sentence that they use in order to describe React is a JavaScript library for building user interfaces. But even if it's a user interface library, it doesn't actually contain UI components. So what does it contain? It contains two main packages. The first one is React, that you access through the react.createElement API that is automatically transpiled from GSX, or you access it through React DOM. And the main function in React DOM is React DOM.render, which you call once per application. The way it works is that it all starts with a tree. You create your component that returns a div that contains a paragraph and another div, and inside your paragraph you say to React that it contains two strings. One is my name is, and the other is Maël. So all this is part of your component, and that's what you do when you just return a GSX literal. Now, what's interesting is that at some point you may just replace one node of the tree. So for example, here, we don't want to say my name is Maël anymore. We want to say my name is Simba. And the interesting thing is that when you do this, React will be able to detect that only the Maël node changed. That's what we call the reconsider. It's kind of a diffing algorithm where React will try to cross all both trees, see what changed, and convert them into generic instructions. So in the case that I described, the generic instructions would be delete the text node Maël, create a new text node called Simba, and then insert the new text node in the paragraph right after the my name is text node. Then, from those generic instructions, React will then craft specific instructions. So for example, the delete the text node Maël instruction will be translated into node.remove from the DOM API. Similarly, the create a text node Simba will be translated into another DOM call, which will be document.createTextNode. And finally, insert the new text node will use the insert before function from the DOM API. So as we can see, it goes through various steps. Yeah, something interesting is that if we are not in a browser, we just have to swap the specific parts of React while still being able to reuse all of the diffing algorithm. So for example, if we were targeting 3JS, 3D library, we would be able to just use dispose instead of remove to create 3.mesh objects instead of calling the create text node function, and to use node.add instead of using node.insert before. So to summarize, the way React works is that our application creates a tree of components. Then React will diff the tree with the previous one and transform all the changes into generic instructions. And finally, it will send those instructions to what we call a renderer, which will interpret all of the instructions according to a specific environment. So in the case of a React DOM, it will use the DOM. In the case of 3JS, it would use the 3JS API. So to give you some examples of React renderers that already exist, we can first quote the main one that you probably all have heard about, React Native. React Native is a custom renderer that instead of targeting the DOM, it targets directly the iOS primitives. Another another renderer is Nodgy, which is a project that was created and released not that long ago. I think it was in July 2019, and that wants to do something very similar to React Native by allowing you to write components using native primitives, except that they made the choice to bind Qt 5 into React. Qt 5, which is a very old native framework, allowing to build user interfaces. Another such renderer is Ink, which has recently been rewritten and transferred into React 16 with a new renderer API. And Ink targets the terminal. So that's actually very interesting, and that's the part that I prefer. Basically, the idea behind Ink is that since so much of our applications try to do fancy things, maybe we could actually build real rich interfaces directly within the terminal, so that we would be able to not only just print text that scrolls, but also use colors, replace nodes as informations are updated, and this kind of stuff. Another renderer is React 3 Fiber. So you might have heard about the 3GS library. I mentioned it a bit before in the presentation. React 3 Fiber is an implementation of 3GS using React. So just like previously you were using React components in order to declare boxes, in React 3 Fiber, you can actually create 3D boxes and put them into the scene at any location by using the declarative model that React allows. Renderers can also do more crazy stuff. So for example, React PDF is an implementation of a PDF renderer, except that it is using except that it is using a full React reconciler in order to generate the output. So in your code, you just create in JavaScript a JSX literal, and then you can render that directly into PDF. It's really crazy. And finally, Battlefield 1 is actually a custom React renderer. As they say in the GitHub issues, most of the UI in Battlefield 1 was created with TypeScript and using a custom React render. They actually did this before the official API for React renderers was created. So they actually had to plug directly within React itself in order to implement it. Then, about 2 years ago, the React team released the React Reconciler package, which made this so much easier. So, one important question that you might have, considering all we've discussed, is should you write a renderer? The answer is probably not, because to be honest, React renderers are a very specific feature of React. And even though it might be useful, you need to carefully consider whether it would be actually beneficial to your application. So when should you use a React renderer? In order to answer this question, we will first discuss quickly the immediate mode versus the retained mode. So in immediate mode, everything you draw on a target is applied immediately. Then the render target will forget everything about what you've just drawn. So for example, if we take Paint, the application Paint, where you can draw pixels, is an immediate mode because everything you draw is transformed into pixels and the software doesn't remember anything about an actual shape. You cannot resize just the shape that you've drawn. You need to redraw on top of it. In retained mode, the render target will keep in memory all the shapes and all their position and will be able to redraw them at every frame. So for example, if Paint is an immediate mode, then Photoshop is a retain mode, because then you can create objects that are stored inside their own layers, and at any point in time you can resize them, move them, and Photoshop will have kept the information about the shape themselves. The DOM is a retain mode API because you are creating a tree where each node is stored inside the tree. So you can just mutate one tree and all the others will be reprinted as needed. So why do I talk about those two modes? It's because React tracks diff from a tree. So as I mentioned earlier in the talk, the way it works is that it will take an old tree, it will take a new tree, and it will compute the difference between the two of them. In order to make that efficient, the renderer API is probably better suited to generate a tree as well. For example, some of the functions in the renderer API are called create instance, append child, insert before. All those things are what you would expect from a tree creation. As a result, React is really better suited to work with retain mode APIs, which often work with trees as well, as we've been able to see with React DOM. That being said, all immediate mode APIs can be abstracted behind retain mode APIs. It just requires significant work. So for example, to give you a quick example, um, you might remember the ink renderer I mentioned, which allows you to draw on a terminal. That's typically something that is in immediate mode, because when you're drawing something on your terminal, you have no way for the terminal to remember that you wanted to draw, for example, one string. The terminal is basically just a set of pixels, except that each pixel is a character instead of being an actual color. So in this case, in order to make a terminal renderer, you have a lot of complexity because you need to transform the immediate mode from the terminal into a retain mode. You need to recreate all the renderer for the terminal before implementing it as a React renderer. So if you're working with something with a tree, it will be much easier to create a React renderer. So we discussed what is React, and the first line inside the React website was a JavaScript library for building user interfaces. So what makes React a user interface library? We've seen that the reconciler is generic, so maybe we can use it for other purposes, right? The reason why React is defined as a user interface library is that the reconciler main interest is if the tree is expected to change in unpredictable ways. And as it turns out, this only really happens in user interfaces. When the user is clicking on a button, then you want the screen to change. Um, when you receive new data, you want the screen to refresh. But when you create another type of, for example, when you create a CLI tool without a user interface, all the data are known beforehand. In these circumstances, diffing a tree is not super useful. That being said, it can still be interesting if you want to make UI components reusable. But even in this case, that's something very targeted to user interface, because only user interfaces have UI components. That's the whole point. So for this reason, using the Reconsider API for non-user interface work is likely not what you want to do. In some very particular cases, it's still possible. For example, you could imagine a game that would be implemented as a React renderer, where each NPC would be one of the nodes inside your tree, and you would div them to remove them once they have disappeared. So it would be a very creative use of a renderer. But in general, you might want to really consider whether you will have a lot of updates uh, in your application. So when do you actually want to use a renderer? You will want to use a custom React renderer anytime we will want to lower the learning curve for building arbitrary UIs. We've seen in games, for example, with Battlefield 1, which implements a lot of their UIs using React. But even smart TV displays are actually using React, and native applications are also using React. So React, the main point of using a custom React renderer is that you will instantly make it possible for developers from a lot of backgrounds to contribute to your applications. So in the case, for example, of smart TV, it's very important because then it means that it becomes much easier for third parties to write applications targeting your smart TV interface. So we discussed a bit about dynamic renderers, and I told you all about you should use a React renderer when you have dynamic data that will change. But what if you don't have dynamic data that will change? Can you still use a renderer? The answer is not exactly. So we are going to discuss this in a kind of a bonus. So as we discussed, renderer of our dynamic data. So what can we use to use React for static data? The answer is we don't actually want to use React. We just have to use GSX. GSX takes a literal HTML-like string, and we'll turn that into a string of JavaScript that goes through react.createElement. So for example, I've highlighted the React object, but we are not obligated to use actually react.createElement. We can replace that by something else. For example, here, with the Babel transform of GSX, if you put a pragma called @GSX image renderer, and you keep the exact same GSX literal, Babel will transform it not inside react.createElement, but into image renderer.createElement. And that's very interesting because you can implement image renderer as you wish, meaning that even though the syntax will be exactly the same, so you will still have a GSX literal, and you will still be able to write your components, you will be able to render it inside your own function. So it's not revolutionary. Basically, it's kind of a syntactic sugar, but it shows that you can actually use a static renderer in React without using the full-fledged React renderer API, which is really suited for dynamic updates and much more complex. I've aggregated a few extra resources that you may want to read on the subject that are very interesting. The first one is an introduction to the Reconsider API by Sophie Alper from the React team that is very interesting to understand how to implement a renderer. In this talk, I haven't actually discussed how you should write one because it's a very complex subject that would have went well past the 30 minutes. Another interesting resource is the awesome React renderer repository, which lists a bunch of other React renderers that I haven't been able to discuss yet. So for example, you have React 360, which is a virtual reality renderer made by the Facebook team. And finally, I've also linked the create React NOP file from the React repository, which is the NoOp renderer for React. So it's very useful to get practical learning. It turns out the source code in React itself is fairly readable inside the renderers. So you can just open the file and look at what it looks like and get a better idea of what renderers actually look like in practice. So that's it. I hope it gives you a better sense of what renderers are, in which case you want to use them, in which case you don't want to use them. And feel free to ask if you have any question about them. Thank you for your time.
Thanks, Maël. That was awesome. So, did you have to write a reconciler at work, or have you played with it yourself?
Yes, I've created a library called My Little DOM, and that was meant to implement terminal render inside using React. And that was quite interesting because when I first started writing it, the React Reconsider package didn't actually exist. So I had to go into the internals in order to emulate it. And it was very difficult. And I've been able to see firsthand the work that the React team did on making React renders more accessible by everyone. And now you can actually implement one by just reading on the different hooks that they implemented and filling them out.
Okay. I didn't know about the static renderer that you mentioned at the end. Could you explain a bit more about how like other use cases than images, for example?
Let me show you. Do you still see my window?
Yep.
Right. So for example, here we have a React renderer, and everything is rendered directly within a terminal. So you can just type anything you want, and you can scroll, and you can click buttons, and all the UIs is handled directly from a React interface. Even the styles themselves are interpreted from the literals that you're used to manipulate when writing HTML. And all that doesn't target the DOM, even though I look like I'm in a browser. It really displays on a terminal interface by just recreating all the DOM API.
Okay, that's very cool. I just sent the link to the My Little DOM on the chat so that people can check it out. And okay, and do you have any other cool project you would like to mention?
So for now, not exactly, although there is something interesting. If we go into the Berry repository, which is where the development for React 2 is happening, you can see
Yarn
that
too.
we actually have TSX files inside our source. This is because some of our commands are actually implemented using React itself. For example, here you can see that this is all React. And we are not using My Little DOM because My Little DOM is a very heavy implementation that does a lot of things, including CSS support. So since we wanted something a bit lighter, we went with the ink renderer that I mentioned that is less feature heavy, but is maybe more stable. And so, for example, if I go into the Yarn repository and run Yarn upgrade interactive, it will be implemented using React.
Okay, very cool. Okay, thanks, Maël. Let me see if there are any questions.
Can you pass the YouTube links from presentation? Yeah, sure. I will pass them in a second.
Okay.
I will also share the slides, so you will be able to also click them directly.
Okay, we will add them to the video description also.
Perfect.
Okay, well, thanks everyone for watching the stream, and don't forget to subscribe to the channel if you're interested in more content. And Maël, thank you for the presentation. Do you have anything else you would like to say?
Well, I'm happy to be there.
Okay.
Thank you.
Thanks, Maël. Bye.
Bye.
Bye bye.